Good morning students. So in this class we are going to discuss about black body spectrum. So if an object burns, it emits radiation. So it depends upon the temperature. If you increase the temperature, so the radiation, that is electromagnetic radiation, increases. So if you heat the object, so it glows in red color, so it's hot. Again we are further increasing the heat, so it glow in reddish orange, that is hotter. Then again we are increasing the temperature of an object, so it glows in white, that is hottest. So that is the intensity versus wavelength curve. So to understand this, we need to know two laws. So first one, Stephen Boltzmann law. So E is equal to sigma T power 4. So that is energy is directly proportional to temperature. Then Wien's displacement law. So the maximum wavelength is inversely proportional to temperature. So first one, if temperature is more, energy is also more, because E is directly proportional to temperature. So at 6000 Kelvin, that is intensity is maximum. So the intensity energy somewhat moreover equal. So at maximum temperature, energy is maximum. So at 6000 Kelvin, that is the surface temperature of the sun. So here sun is a black body. So the black body spectrum, so we are analyzing the black body spectrum of sun. First one, so the 6000 Kelvin, that is intensity is maximum. Then that is a wavelength, that is maximum wavelength is inversely proportional to the temperature. So if we increase the wavelength, temperature decreases. So goes in x-axis. If we increase the wavelength, temperature decreases, that is 4000 Kelvin. So see, this is the maximum wavelength, then increase the temperature. So at this wavelength, it's 4000 Kelvin, that is a carbon arc. Then 3000 Kelvin again. So the wavelength increases. So that is from the lamp filament. So first at 6000 Kelvin, that is 508 nanometer, that is the maximum wavelength. So it's a range, it's a visible range. So after red, that is infrared radiation, then before violet, that is ultraviolet radiation. So the violet to red, that is VIBGYOR, that is a visible range. So we are evolved from the sun, so we are visible only that visible range, that violet to red, because according to Wien's displacement law, so lambda m is equal to b by t. So if you substitute the value b, Wien's constant, the temperature, that is the maximum temperature of the sun, that is surface temperature of the sun, that is 6000 Kelvin, you will get 508 nanometer. So they have a range. So the sensation of vision for human beings, that is under that violet to red, that is 4000 Armstrong to 8000 Armstrong. So the next, Fraunhofer lines. So spectrum obtained from the sun, it consists of large number of dark lines. So the dark lines, that is a line absorption spectrum. So the dark lines in the solar spectrum is called Fraunhofer lines. So the absorption spectra of various elements is compared with the solar spectrum. So that is get from the sun. So it helps to identify the elements present in the sun's atmosphere. So what's my Fraunhofer lines? So dark lines in the solar spectrum is Fraunhofer lines, and it helps to identify the elements present in the sun's atmosphere. So in this class we have discussed first one, black body spectrum, then Fraunhofer lines. So up to this we have completed the lesson number 5, electromagnetic waves. So the next class we will discuss lesson number 6, optics. So